Hello, pre-calcers. We are on day 9 of chapter 7, Algebra and Trigonomic Functions. So our first example today is going to be about using algebraic simplification of trig expressions. In other words, instead of writing out sine squared cosine, we can rewrite it as s squared c. Okay, just trying to make our lives a little bit easier. So let's look at example 1. We're going to rewrite this in terms of s squared and c. We're going to have 3 sine squared cosine minus 5 sine squared cosine. This and this are the exact same, but it's easier to see in terms of just letters versus in terms of the trig function. So it's clear to see here, I have 3 of this group minus 5 of the same group, leaves me with negative 2 of that group. Keep in mind that group is sine squared theta cosine theta. So use this method to help you simplify, but you do need to leave your answer in terms of the trig function. Do not leave it in terms of s squared and c, because who knows what that is. As long as you tell me that it's sine squared theta cosine theta, then we're in good shape. Let's look at number 2, or part B. Carry out this multiplication. Instead of writing sine theta and cosine theta, I'm going to simplify it to just be 2s minus 3c. That's being squared. Use this if it's helpful. It's clear now that I'm going to FOIL. It might have been a little messy before, but I'm definitely going to FOIL here. I'm going to rewrite my 2 terms. And I'm going to FOIL. First to first is 4s squared. 2s times negative 3c is negative 6sc. Another negative 6sc. And a plus 9c squared. Combine your like terms. We get negative 12sc plus 9c squared. So this is our simplification. But we're not going to leave our answer like that. Our answer is going to be in terms of sine and cosine. We have 4 sine squared theta minus 12 sine theta cosine theta plus 9 cosine squared theta. And that is our answer. That's our multiplication of 2 sine theta minus 3 cosine theta, all being squared. So use this if you would like. I think it just makes your work a little bit clearer and then helps you understand it a little bit more. We can do the same thing when we're factoring. If we want to replace it with the letters and make it easier for ourselves, let's do that. My goal here is to factor tan squared a plus 5 tan a plus 6. To help us focus on the algebra, let's replace tangent of a by just the letter t. You can really choose any letter. I think t just makes the most sense because of tangent. So if I rewrote that statement as this, it's pretty clear to see when I factor, I need terms that add to 5, multiply to 6, which leaves you with t plus 3 times t plus 2. Those add to 5 and those multiply to 6, but you don't leave your answer like this. That is the helping. Here is your final answer in terms of the trig function with tangent in it. Let's move right along. Let's have you try some. Take a quick moment. Please pause the video and you try to simplify number 1 and number 2. Okay, hopefully you simplified. How I'm going to do it is first clean up my variables. So instead of writing cosine, I'm going to write c cubed instead of sine squared, and I have 7s squared c through to the 3rd power. Notice these are the same. Yes, the order is a little bit different, but with multiplication, that doesn't matter. You have 2 of a group, take away 7 of the group, you will have negative 5 of the group. Oops, this should be an s. This is helping you with your algebra. algebra or algebraic steps. And now you need to put in terms of cosine and sine. So -5 cosine cubed sine squared with your thetas. Number 2 is a factoring. When we're simplifying, we're trying to get to as simple as possible, those factors. Because there is a 3 in front, I will have to do my split the middle method. But first, I'm going to rewrite as just c squared, so it looks a little bit nicer for me. Thinking of your split the middle method, you're going to take the first term and the second, gives us -6. My goal is to find terms that add to 1, multiply to -6 to split that middle term. So I'm going to leave my beginning and my last term, but I'm splitting up that plus c into plus 3c minus 2c. That is splitting that middle term. We're going to factor with GCF on the first two. So you get out a 3c, that's the greatest common factor. Greatest common factor in the next two would be a -2 because we need the inners to match. And they do. Yay! If they didn't match, then maybe you want to factor out a +2. Whatever needs to be done so that they match. Now that they do, I can factor them out. You get a c plus 1 with a 3c minus 2 left over. That's the algebraic help. Do not leave your answer like that. Rewrite it in terms of the variables used. So this is going to be cotangent beta plus 1 times 3 cotangent beta minus 2. And you just factored. The next one. Some of you probably looked at it and were like, yay, I get to solve identities. Ish, because you're not having anything on the right side or the left side. Our directions is just simplify. So this is very messy. We're going to do everything we can to get it as simple as possible. Where you can't go any further, then you're done. It's not showing that right equals left. It's more just simplifying one entirely using the same steps that we did with chapter 6. So let's jump on in. Think of all the steps we had. Change into sine and cosine, common denominators, multiply by reciprocals, identities, factoring. All of that stuff is directly from chapter 6. Let's see what we can do. First thing, I'm going to change in terms of sine and cosine. Even the denominator. Cotangent is cosine over sine. Realizing I now have a fraction plus a number and another fraction plus a trig function. Both of these need my common denominators. So I'm going to multiply this one by sine A over sine A. And same with this denominator because I need that common denominator in my denominator. Numerator will become 1 plus sine A over my denominator of sine A. My denominator is going to be cosine, and notice how I write this. This is just an idea. Cosine factored out, leaving a sine A plus 1. There should be an A right here. Think about what I did there. I got my common denominator, so if you want to show that step where it says sine A cosine A plus cosine A in the numerator, then what I did is just took out that cosine. The reason why I did that is I'm already looking ahead. I'm looking ahead at this term, and I realize when I multiply by that reciprocal, I'm going to want to cancel. If you don't see that, that's okay. Please add in those steps going to there. Totally okay. whatever your level of comfort is. Now that I have a fraction with a fraction, I'm going to multiply by that reciprocal. That idea that I had and kind of simplified to. So here's my numerator times the denominator flipped, that reciprocal. Sine A's cancel. This group of 1 plus sine A and this group of 1 plus sine A go away. All I'm left with is 1 over cosine. 1 over cosine is secant of A. And I think I'm done. I don't know what other step I could do. That is as simple as it can be. So first thing was sine and cosine. Common denominators. Multiply by the reciprocal. And then put it in terms of secant. Just like identities, but it's not telling you what to simplify or what it needs to equal. It's just saying, hey, get as simple as possible, and then you did your job. Now, what if we tried simplifying trigonometric expressions like this one, but maybe using just our letters? That might help, right? Think of what we just learned with using like C for cotangent, S for sine, anything like that. Why don't we try that? Maybe it'll make it a little cleaner. So here, I am told to add S plus 1 over C. Well, you know you can't add until you have common denominators. So multiply by C over C. So you get SC plus 1 over C. Can we do anything else? No, it kind of looks like we're stuck. This is as simple as it can get. So here's the algebraic, but you're going to put your answer in terms of those variables. Cosine sine, it doesn't matter the order, plus 1 over cosine theta. You could have even done that with the example above on the right. Just make sure you watch out for your cosecant, cosine, and cotangent. They all have the same letter C to start. So up to you. Just an idea. Okay, the last two. Pause the video very quickly. See if you can solve these. Okay, hopefully you paused. For this one, we've done so much of this in chapter 6. So heading into chapter 7 here, I would quickly draw my picture. I'm told I'm between pi halves and pi. Pi halves and pi. So that is definitely the second quadrant. I'm going to draw my picture. Here's my angle T. I know the sine is root 3 over 4. And I want to find tangent. You can use identities. Our sine squared plus cosine squared equals 1. You could use Pythagorean's theorem. Anything you want in order to find this missing x length. I'm just going to do Pythagorean's theorem, which is root 3 squared plus your unknown squared equals your hypotenuse squared. So this is 3. X squared is going to equal 13. When you put the square root, you put the plus minus, and now we need to see what sign. Is it positive or is it negative? Because I'm in the second quadrant, all students take calc. The only thing positive is sine. The cosine is going to be negative. This x value here is going in the negative direction. Make sure you say it's negative 13. I'm going to erase this and just put what it is, negative root 13, because now I can find the tangent. Tangent of t is opposite over adjacent, so root 3 over negative root 13. Can't have Square root in the bottom, we know that. So times by root 13 over root 13. I'm going to move that negative to the top to get negative square root of 39 over 13. No square root in the bottom. It's okay to have a square root in the numerator, and this is where we're at. Let's see how you did on the simplifying. If you did it right, you should have got to 2 cosecant theta. I'm going to leave this as an exercise. If you can have this one done and show me in class, I'll give you some extra points. This should be your final simplified answer. I'm going to tell you some ideas you can use. I would go into sine cosine. Then I would find common denominators. Then I would multiply by reciprocals. Then I actually would get another set of common denominators. Maybe use an identity or two, or just simplify. And we'll see how you did. If you did it right, you'll end up with 2 cosecant of theta. We will go over this one in class. Don't worry, I'm just up for a little challenge. Have a great day.